All right. So, hello everyone, afternoon or morning, depending on your time zone. My name is Andrew Owen. I am a facilitator with the OSPool, and I'm going to be talking to you today about how we move data around the OSPool and how you can get connected with that movement. So, title is Use Your Data Anywhere, and the focus is mostly going to be on the OSDF and Pelican. We welcome any and all questions, so please don't hesitate to ask. Feel free to unmute yourself or raise your hands or type a question into the chat. Daniel Morales and Mats Ringe are also facilitators, and they'll be able to help answer questions in the chat. These slides will be well, they are available online. I'll put that link in the chat again. You can find them here. There'll also be the slides and the video that I'm recording will also be posted online to our training page for future viewing. All right. So what we'll be talking about today is first a very brief introduction to the OSPool and high throughput computing. And how we run jobs on the OSPool. This is to set up the discussion about moving data around the OSPool via the OSDF, which then leads into discussion about Pelican, which is the software running the OSDF, and finally, how you can actually contribute to the OSDF as well. All right, so OSPool and high throughput computing, hopefully most of you folks here are familiar with the OSPool, but if not, then just as a brief introduction. First, the OSG consortium is the collection of members who do all sorts of computing stuff, but they operate a variety of pools of shared computing and data capacity for doing distributed high throughput computing. Basically, there's a lot of folks from a lot of institutions who've connected the hardware together so that everyone can take advantage of them for open science. So, for example, a lot of campuses have their own compute clusters. They probably spent a couple of $1 million at least in setting that up and getting it running, and probably another a couple $100,000 a year to operate it. And that's a big investment to make to do research. And it's an investment that they don't ever want to sit idle. But of course, sometimes just the natural ebb and flow of things. Sometimes the clusters are less busy than other times. And the folks that make that investment would really like to be able to harness that extra time that those clusters aren't being used. And from the researcher point of view, if you're a researcher out of Syracuse and, San Diego has a lot of available computing power that you would love to take advantage of, the traditional way of getting access would be to make a separate account and do things separately on that system. But that's a logistic nightmare, especially if you want to do this for more than one institution. So one way around that is to somehow pool together these resources for these institutions in such a way that when they're idle, they can be used by anyone who has access to this pool of resources. And we can pretend that this is a virtual cluster, but distributed across the country. And that's what the OSPool is. So the OSPool is this collection of institutions who are contributing time on their compute resources to a HT Condor pool that anyone in the country can get access to, any researcher in the country can get access to, and be able to run their jobs pretty much anywhere in the country. There are a lot of contributing sites. Most of them are contributing compute power of some sort. There's a handful that are only contributing storage, but those are pretty useful in the context of the OSDF, as we're about to discuss. Okay, so running jobs on the OSPool. If you haven't done this already, you get an account by requesting one through our website. We'll give you access to an access point. So this is a login server that gives you access to submitting jobs on the pool. And as the user, there's some things you have to prepare for submitting jobs. So the submit file, got to get your software set up and your scripts and your data in the right spots. And you give that job to HG Condor, and it goes out to this collection of, to this virtual pool that we have, which is this collection of many contributing institutions. And it finds a machine somewhere in those contributors that is free and able to run your job. And then it will transfer the files to the working directory of that machine. So your software, your scripts, your data, and we'll execute it. And when it's finished up, it's generated some output data, it's generated some information. HCOM will transfer that back to the access point so that you, the researcher, can take a look at what happens and do your science. All right. So it's important to consider the scale of the OSPool when we're talking about data movements. High throughput computing is, in its core paradigm, is the ability to run many, many calculations. And HG Condor which is what runs the OSPool, is designed with this in mind. And the OSPool regularly runs anywhere from 500,000 to 1 million or more jobs a day. And this is from, I think, last Friday or Thursday, the snapshot here, and you can find the current one by going to that link that I have on the slide there. All right, so that's a lot of jobs. Each job usually has at least one file. At minimum, it's the executable file you want to run, but usually there's other files that go along with that. There's the data set you want to use. There's your software container for deploying your software. And so anywhere from 1 to 10 million files are transferred per day as part of running those million jobs per day. And so there's a lot of data movements. Some of this is input, some of this is output, but we're talking about a lot of file transfers across the OSPool. And on the OSPool, if you're using one of our general access points, you're submitting from somewhere in the Midwest here, and those jobs could go and run anywhere in the country, which means those file transfers may be going from this star in the Midwest to anywhere in the country. Now, with this scenario that we have here, we're talking about one day, 1 million jobs and 10 files per job. And that's pretty close to what those stats were from that snapshot I took last week. What is the volume of data that's being transferred to support this? And this kind of depends on what the average file size is. If we're talking text files, just simple scripts, then it's not very much data at all, right? 1 kilobyte files on average. It's hardly gigabytes of data being transferred. But as you go up in orders of magnitude here in the file size, and these are fairly reasonable jumps to make, 1 megabyte, maybe that's a CSV file. 1 gigabyte, maybe that's a small container. 10 gigabytes could be a large container or a large data set that you're transferring. And you can see the volume of data that's being transferred jumps into multiples of terabytes. I don't have a number of what the actual average size of a file transferred through the OSPool is, but very, very quickly, 10 gigabytes per job, we're getting a lot of terabytes of network transfers on the system. And just a brief note, I'm using bytes here. A proper network computer scientist would use bits. So multiply by 8 to get what actual network hardware runs on. And for a 10 gigabyte average file size, that's nearing a petabit per day of transfers. Okay, in addition, OSPool is competing with a lot of other internet traffic. OSPool contributors are typically publicly funded, so the hardware may not be the latest and greatest network hardware for transferring data. And you could be transferring the data from New York to San Diego or further. We've got some folks out in Hawaii that are submitting to the OSPool. So their data is moving from Hawaii maybe to New York and beyond. So not only is there this volume consideration, there's also the distance consideration for transferring these files. And if the files can't be transferred to the start of the job, that means the job can't start. And so the longer it takes to transfer those files, the longer it takes the job to get started, the longer it takes to get through your workflow. All right. So data movements in large files. So transferring large data, typically an HT Condor job has a common set of files. There's usually some sort of input data of some kind. Nowadays, most folks are deploying their software using containers. So a container image file. And depending on what you're working on, you may have a reference database. We see this sometimes with some of the analyses. It's just a set of data that you always need to ship with because it's used as a reference, it's used as a lookup, you're making comparisons to it, something like that. And it's not uncommon for this to total, 1 to 10 gigabytes or more per job. So if we sort of narrow our focus a little bit, we're still thinking about scale, just not the scale of everyone. We're going to think about the scale of me as a single user. If I want to submit 1,000 jobs and each are using the same 1 gigabyte file, well, on the OSPool, I'm going to be submitting here somewhere in the Midwest. And then, it could run anywhere in the country. And if I've got 1,000 jobs, let's say it's there's a bunch of resources available in San Diego. So I want to send out that gigabyte file to start at my job there. Then, I got 1,000 jobs. And as that keeps going on, I can quickly flood the network between here and San Diego, or at least the, academic internet network anyways. So, to get all, well, I guess in the numbers here, I have 10,000 jobs and a 10 gigabyte file. All right, so I need to adjust my previous slide here. But, we do some simple back of the envelope calculations here, and we're talking about 100 terabytes of network transfer to run my workflow. If we scale that down for the scenario I had on the previous slide, I think that's 1 terabyte of network transfer, but it's still a lot. Okay. What if now all of these jobs running out in San Diego, they're using the same 10 gigabyte file that I had started out with here in Madison or Chicago. And it's not changed for each job. Each job needs it. So what if I could reuse a copy of that file locally? And this is effectively the concept of the Open Science Data Federation, or the OSDF, working with the Internet 2 and several other providers. We've set up a system of data caches throughout the country to stage large, repeatedly used files closer to the actual compute resources. So again, we're submitting out of somewhere in the Midwest here, and we sent that 10 gigabyte file out to the cache in San Diego. And now those compute servers in San Diego, when they need to access the file, they just go to that cache instead of going all the way back to the Midwest. And so, with the 10,000 jobs and a 10 gigabyte file, we only transfer that file once to the cache, and then it just keeps getting reused. Now, it is important to note that, this is saving the transfers between the Midwest and California. There's still the transfer between the cache and the data center where the computing is actually happening. But that's going to be a much shorter round trip. It should have some pretty decent speeds. And then oftentimes we try to set up caches locally in the compute cluster. So I'm pretty sure the cache in San Diego is in the same data center as the contributions we get from the San Diego computing cluster. And we're working on ways to improve the local level caching with HT Condor and using Pelican, which I'm about to talk about. All right, so what is the OSDF in terms of its components? So there is a set of origins. These are the original location of the data, and they know how to access the data that we want to ship around through the OSDF. And then there's a set of caches that we've set up, and these are the servers that can keep local copies of data. These are usually pretty beefy machines with 100 gig pipes and a lot of local disk. So they're a much better as a web server, as a data transfer server, than a lot of the sort of servers that a lot of researchers keep their data on. And the OSDF is integrated both with the OSPool as well as with HT Condor in its job submission. And the OSDF system is operated by the OSG consortium alongside the OSPool. They're technically separate systems, but they're very closely independent, or very closely dependent on each other. In the last 12 months, the OSDF supported the OSPool for 112 projects from 66 institutions, representing 27 fields of science. And it did so by transferring 150 million objects, totaling 60 petabytes. So a lot of transfers happening through the OSDF. Something I'm not quite sure about is this number measuring the actual data transferred, or is this the total data that would have been transferred? I'm still not quite sure. I need to bug someone about that. But you can see these stats, these live stats, by going to this link here for OSDF projects. All right. So that's the hardware for the OSDF. How is it organized conceptually? Well, data in the OSDF is organized under a single namespace, independent of the storage that actually provides the data. So what this means is that the user who wants to access data through the OSDF only needs to know the address of the object within this single namespace. We refer to this as the URL for the objects. They don't need to know, is it stored in an S3 system? Is it stored on POSIX? Is it stored on Ceph? It doesn't need to know, they don't need to know any of that information. This is set up and plugged in by the origin. All the user needs to do is say, here's my URL. So the URL looks something like this. We have the OSDF protocol in the front. The first half of the URL is the namespace prefix. You can think of this as analogous to a bucket if you're familiar with S3 storage. And then there's the name of the object within that bucket. For folks with OSPool accounts, and we'll talk more about this in a bit, OSPool accounts automatically get access to the namespace prefix OSPool / their AP and whatever the number is for their access point. /data / their username. So there's a corresponding directory that they can access through the AP, and they just place the data in that directory. And then in their submit file, they use this OSDF URL to transfer data as part of an HT Condor job. And HT Condor handles talking with the OSDF automatically. And one of the nice things about this is if there's an issue, then with transferring that object, that will reflect back as a hold message, or HT Condor will automatically try it again somewhere else. So for most of our OSPool users, this is what we're going to be focusing on here. So for transferring large input data, the process for this, you start by, well, first, the 0th step is you have to log into your access point. But then on that access point will be a directory that looks very similar to that namespace prefix. So you place a large file in that path. And then in your submit file, if you need this as an input file, you use the OSDF protocol, and then you give that essentially that same path after the protocol. And then as part of the HT Condor job, it'll automatically transfer that data when the job starts up. And before the execution actually starts. And so HT Condor is automatically handling file transfer for you. You don't have to do copy or download or anything like that. We do have a guide for this on our website. You can also find it through our website by searching for OSDF. and that will also have this information. We're going to do a hands-on portion of this in a minute here. Question from the chat, is large file a folder? I think in my example, I meant that to be actually a large file. But it could be a folder. Then the transfer behavior is a little different. I'm not quite sure if it'll work the way you expect it to if this was a folder. So for the purpose of this slide, large file is itself a file. Okay, so by default, the OSPool user who placed the data is the one that can use that data, is the only one who can use that data through the OSDF. So someone else putting the same URL in their submit file isn't going to be able to access the data because we've set up the access to be only for that user account through the access point. For large output data, so this is sort of the same thing, but in reverse. There is large data in the job that you want to be transferred back via the OSDF. In your submit file, you would specify the name of the large file that was in the job directory that you want to transfer back. And then also in your submit file, you need to do something called transfer output remaps in order to remap or to change the destination of the file to be in the OSDF. And by providing this OSDF address, what this tells it to do is to write this large file into that namespace prefix in the OSDF via the OSDF protocol. This syntax is funky. I personally want this, I want to fix this. I want to make it a little easier for our users to use. We're working with the development team for OSG Condor to try and figure out what the right syntax should be to make this feel more reasonable. And just like with the transfer of the input files, OSG Condor and OSDF will automatically handle the transfer of the data at the end of the job. And as long as you're declaring that in your submit file, if something goes wrong with that transfer, it'll reflect back as either a hold message or a retry at another location. And again, this information is in that same guide on our website. All right. This leads us to the hands-on portion. I'm also going to be demonstrating this, so you certainly don't have to do this if you don't feel up to it. But it should be fairly straightforward. We're going to use our guest notebook service. So to do that, you're going to go to this link here, notebook.ospool.osg-hc.org. I'll also type that in the chat. So go to that website for login. I believe it needs to be an institutional ID that you sign in through CI logon. I don't think Gmail or Orchid will work. Let's see here. Once you've logged in, you'll want to select guest notebook, and that will take a few minutes to start up. Once it does, we're going to navigate to the tutorial-r-noah directory, and inside of there is this r-noah ipynb file that we want to open up and work through. All right, so I'm going to try and do that. Let's see, let's switch to presenter view here. See if I can squash my screen down enough here. So I'm going to go to that address, and I see something like this that I should log on with CI logon. I'm going to go ahead and do that. It will redirect you to a page like this. Select an identity provider. My identity provider is the University of Wisconsin-Madison. You should do whatever your institution is. It's up to you if you want to remember the selection or not. And behind the scenes, what that did is it talked to my university account system. I'm already signed in another tab, and so it just automatically detected that sign in and gave me access. So we then see a page that looks like this. So server options, guest accounts, AP40 full access. Depending on if you have an account on AP40 or not, you may or may not see that option. I do, but I'm still going to go with the guest account because that's going to automatically load the materials. So I'm going to start that up, and that may take a minute or two to get going. Behind the scenes, what we've done is the GitHub repository that I have the materials in is automatically cloned on startup. So I'm going to make this full screen now. There's this tutorial R NOAA directory on the left-hand navigation pane. And this has the materials that we're going to be using for today. In here is a notebook file, this r-NOAA file, and I'm going to go ahead and open that up. All right. So this tutorial is originally for demonstrating how you can use R and the OSDF to do climate analysis. And it's just a toy analysis using official data from NOAA, National Oceanic and Atmospheric Administration. I did check that I can still access those files as of 10 minutes before this started. So hopefully that hasn't turned off in the background. Joseph, you have a question.
Yes, is this notebook and login procedure going to be available later after the tutorial is done, or is it only active for the tutorial?
It should still be available, yep.
Okay.
And the guest notebook feature definitely will be available. I guess I can add into my slides. There is a GitHub repository behind this. Tutorial R NOAA. There we go. So there is a GitHub repository that supplies these files. So you know, even if for some reason the guest account no longer automatically loads this, you could still use the guest notebook and do a git clone to download the materials. Okay, so what we're going to do here for the hands-on portion, hopefully everyone's had an opportunity to log in if they wanted to. You're welcome to read through this in detail if you want to. But the idea is that there is some data accessible through the OSDF, through an origin that we've set up. And there is this NOAA data set that can be accessed through this origin. And it's got lots of historic climate data in the form of CSV files. So there's kind of two ways that we can interact with this. We could download in advance to this server that we're running in the guest notebook here, or we could download it as part of a job. And so we're going to start off by just doing this as part of a job. There is a example.r script for doing this. Basically, it takes the ID for one of these stations, and that corresponds also to the name of the CSV file. And it generates a pretty picture that is probably not too useful. It separates the highs and the lows for the different seasons. And you can see that the summer has more higher highs and the winter has lower lows. We're using a container that has R in it. And what we want to do for an HD Condor job here is we want to have a list of weather stations that we want to run this analysis against, and then a template or a submit file for doing this analysis for each of these as an HT Convoy job. So, yeah, Joseph?
Oh, I'm sorry, my hand should be down.
I thought I heard you say something.
No.
Okay. So there is this GHC and D stations.txt. This has the list of station IDs. So if you really wanted, you could open that up in your Jupyter notebook. It may get angry with you because it is on the larger side. There are a lot of stations here. I think it's something like 150,000. But these stations have an ID, they have some GPS coordinates. I don't remember what this column is, and then some sort of name attached to it. So we're going to do a list of 10 stations from a particular subset. This command will extract some stations from the Wisconsin range of the list and save them as station list.txt. And if I take a look at that file, I see these USW IDs for these different stations. I believe this first one here is for the airport in Madison. Okay, so this is the list of stations that we want to analyze. You, of course, could change this to some other subsection or cherry pick whatever you wanted in here, as long as it's a valid member of this GHCND stations.txt. And GHCND is the name of this data set, Global Historic Climate something data. Okay, so in the job template, in the submit file here, if you haven't run an HD Condor job or need a reminder, in there we declare what the software environment is, what commands or scripts the job should run, the input files that are necessary, because we need to transfer those as part of the job, because we're in this distributed system. Outputs, similarly, if we don't declare this, then it will just get returned to the same directory you submitted the job from. Otherwise, if you want to change where it ends up, you'll need to use the transfer output remaps. Oh, didn't mean to do that. The information about the job. So this is how HD Condor is managing it. Also messages that may have been printed, normally would have been printed to the screen, will get saved. And then the resources of the machine that we want to execute on. So this information is communicated through the submit file, and you can cat the example.sub to see what this looks like. We're using a container image that we've also placed in the OSDF because it's a larger file we want to ship around. Executable is going to be this R script. We're using arguments to pass the station ID to the script because it needs that. Transfer of the input files, the example.R script relies on this myfunctions.R script, as well as the URL in the OSDF for that particular station ID that we want to look at. We got to transfer output remaps so that the output file that's created gets remapped into the results directory. We're recording the information output error log in the logs directory, and we are requesting 1 CPU, 2 gigs of RAM, 2 gigs of disk. As for the value of station ID that was referenced throughout the submit file, for our first job, we're going to queue this from this single station ID. So we're testing that this submit file works for 1 station ID. And once that actually works, we'll run it again, but for all the station IDs we want to look at. All right, so for this first one, we're going to submit the job with Condor submit in example.sub. You can run this in the notebook itself, or you could open up a terminal tab and go there. You can use Condor Q to see that the job has been submitted, and here we see that it's running. You can also open up a console, a terminal tab here. And I probably didn't do this fast enough, but there's a command condor_watch_q that you can use that will give you a live update of the status of your job. You don't want to run this command in the notebook cell just because that is, it doesn't behave well with the notebook format. Once this is green, that means it's done. Hopefully yours doesn't take too much longer than mine. If I rerun my Condor Q commands in the notebook, I'm going to see that there are no longer any jobs listed. That's normal. When a job finishes, it leaves the queue. I'm going to switch that back here. So once completed, the output image is going to be sent into the results folder, and we should see that there is now a .ping file for that station ID. And I can navigate to that file in my left file pane here and open that up. And you can see that it's a rather wide image that was not optimized for this viewing format. But it's a histogram that shows the red are the highs and the blues are the lows. And if we scroll down to the bottom one, you can see we're going from -40 degrees Fahrenheit to 90 or 110, I don't quite remember. And if you downloaded this file, which I'm going to do because I want to actually show it in a reasonable way. If we look at this in a bit, zoom out a bit on this view here, we can see that during the winter, the temperatures, both the highs and the lows, are shifted to the colder temperatures. During the summer, the temperatures are shifted to the higher temperatures. This is not groundbreaking insight here, but I'm also not a climate scientist, so this is the best thing I could think of to come up with a pretty picture. An actual climate scientist would do something a bit more sophisticated than this, but in principle, the format is still the same. Okay. So that was for submitting one job. And again, we're pulling that original CSV data through the OSDF. And if we wanted to do this for more stations, we had that station list.txt file that we created earlier. It's got a list of 10 stations that we can analyze. Well, in our submit file, we change our queue statement from this station ID from parentheses ID to queue the station ID from that list, from that text file. So I'm going to copy this and I'm going to open up that submit file. And I'm just going to replace the previous queue statement there with this from station list.txt. I'm going to save that, switch back to my notebook, and I can submit that again. So here, this time we see that 10 jobs have been submitted. There's going to be one job for each ID that was in that list. And again, I can use Condor Q. I really like the Condor Watch Queue view. So let's see here. Control C to cancel, and then run it again. You may have noticed that Condor_Q said that there have been 4 running jobs, whereas Condor Watch Q says there's none. That is a discrepancy between detecting when files are being transferred between the two commands. And in the next release of HD Condor, this will be fixed for Condor Watch Q. It'll correctly detect when the job is in the file transfer state and display it accordingly. All right. So hopefully this doesn't take too long. And I did run this workflow before the training to hopefully make sure those files that we're downloading are cached somewhere in the OSDF. So it shouldn't take too long to transfer. Let's see here. So Condor Q shows I got 7. There's an option called no batch. And if you do that, it will show you a bit more detail about the states. This lesser than sign means that these files or these jobs are transferring their input files. And hopefully it doesn't take too much longer. While we're waiting, are there any questions on what we've done so far?
Okay, I have a couple of questions on my list, while we're waiting. So Robert and I are part of the LIGO Scientific Collaboration. We have our own accounts over there. Is there any advantage to getting an OSPool account in addition? We do have APs that can submit.
Yeah, so if you have, your organization has its own access point to the OSPool, unless it's not very well supported, I don't think there's any advantage to switching. If they're stuck on HT Condor 8s and they're still stuck on CentOS 7, you may want to consider switching or really bugging someone to upgrade. But I think, staying within your organizational management there is probably a better approach. Just because there's things that can be configured at the access points for particular users that may be making your life easier and you didn't know it. Whereas and you switch to the general access and now all of that custom configuration is no longer there. And you've got to try and bootstrap it up some other way. So,
Okay.
yeah, like I said, unless it's not well supported, then I wouldn't get a general OSPool account. The one exception to that is if you are developing some sort of workflow that you want to make broadly available to the public. In which case you probably do want to prototype that on a general access point. Because that experience is probably going to be different from your organizational access points. But of course, not everyone in the public is going to be able to get access to your organizational access point.
Okay, that makes sense. And then we still got time for another stupid question. Okay.
Yeah, we got time for another one.
Okay, so our OSDF namespace is authenticated.
Yep.
And the question I have is, does the authentication take place on the access point, or does the execute point need to have side tokens to get containers and data if I don't access Pelican directly?
Yeah. So first, that's not a stupid question. Second, the answer to that is a bit complicated. I'm gonna punt it till later in the presentation. So I have a few slides that might help with that process, or at least give the context for the complicated answer.
Got it.
Okay.
Thank you.
Yep. All right, so all of my jobs here have finished. I'm gonna switch back to the notebook view. Okay, so we can do ls, lh, and the results. We see there's a lot of ping files created. Great. And hopefully if I click through those, I will see some more histograms. Of course, these are the super zoomed in ones. I could download them and look at them, but they're not going to be too terribly different. They're going to show the same general trends. All right. Looks like we got a question from Jing. How can I help?
All right, so I have a question about transfer input files again.
Okay.
Say I have many files
Yep.
and it's not realistic for me to list them all there. Can I just use a folder name or like wild cast, like a star sign there to match all the files in the directory?
Yeah, so you can list a directory, and I'll show you how you can do that with the OSDF as well in another slide here. We currently do not support globs or expansions.
But folders are fine. Folder names are fine.
Yeah.
Okay.
Oh, and Wayne has the brilliant idea to open the image in another tab. Oh, great idea. All right, so you can right click on the image, open image in new tab, and you can get a nice view of what that looks like. Okay, so that's it for this half. of the hands-on portion. I'm going to switch back to the slides here. If you're still catching up, the commands are in the notebook cell, so you're welcome to run them as they come up. All right. So that was the introduction to how to use OSDF on the OSPool. We are now going to switch to a bit more advanced usage through the Pelican functionality. Okay, I very briefly mentioned Pelican at the start of this presentation. What even am I talking about? Well, just like how the OSG uses HT Condor as a software that runs jobs on the OSPool, we are transitioning, and mostly transitioned to using Pelican as a software that runs the OSDF. So prior to the development of the Pelican software, OSDF was all custom software stacks that were very dependent on other softwares and their developments. With the use of OSDF in that development, we decided that we needed its own software, and that software is Pelican. So for OSDF, the benefits of using this newly developed software gives us a more reliable and robust software stack. There's lots of room for new features and improvements because we have control over the software. And it's more extensible, both for contributing to a system like the OSDF, as well as for integrating with data stores and other ways of accessing the data that's submitted in an HT Condor job. There's a lot of other powerful ideas behind Pelican here, but the short version is it's essentially a software designed to support something like the OSDF. So a little bit more about what Pelican is. So technically it's the Pelican platform, and you can find more information on the website, links there. But in general, the concept is that it's a software platform for creating a data federation. So by data federation, think something like the OSDF. And a data federation serves to unite folks who are contributing data with the folks that are consuming the data. And it does so under a single namespace. So there's only ever one protocol for accessing data within the federation. All you need to do is declare its particular location. For data contributors, if they have data stores or storage devices, they can connect those existing data stores to the data federation while still maintaining control and controlling access to that data. They still own the data. They're not giving up rights to the data or anything like that. They are plugging it in and making it accessible under the rules that they come up with. On the consumer side, for them, like I said, it's a single protocol for accessing the data. It's always going to be the same commands, regardless of whether it's an S3 backends or it's a POSIX or it's a Ceph, or name your storage backend of choice. The user doesn't need to know any of those details. For them, they just give it the URL within the federation, and that's all they need to do to access or upload data. Okay. Well, for you as OSPool users, why do you care about this, right? Pelican is sort of the software behind the scenes. It's even more behind the scenes than HT Condor is. Why do you care? Well, there's more functionality that's coming out of this. There's a lot more accessibility, ways of accessing the data, other than through an HT Condor job. And what we consider to be the most important here is it's easier to contribute data into the OSDF ecosystem. So if you've got a public data set at your institution, you want to make it available for open science across the country, you can do that through the OSDF. And with Pelican and these things that I'll be talking about here, they don't even have to have an OSPool account to be able to access that data through the OSDF. And that's thanks to Pelican. So I'm going to go through these points here kind of step by step. For our most of our OSPool users, the feature that they're going to like, there are some options you can enable through the use of HTML queries. So this is something, a query is usually you append $sign and then some sort of option or commands to the end of the URL. In the case of Pelican, it's going to use that to affect the transfer of that individual object that was listed with that URL. So there's two main ones that folks are going to find useful. There's this pack, and it can take other values than auto, but for most cases, auto is probably good enough. Pack will automatically, if you're downloading it from the OSDF, it will automatically unpack or decompress a compressed file. In the reverse, if you're uploading data into the OSDF, it'll automatically compress the objects into a single file for storage in the OSDF. So we've gotten a lot of use for that. This question mark recursive being added to the ends. This is how you transfer an entire directory via the OSDF. So if you've got a directory of files in your OSDF location and you want to transfer all of them as part of your HT Condor job, you give the path to that directory and tack on $sign recursive at the end. Okay. The next thing, I said there was more accessibility of the OSDF using Pelican. It's no longer restricted to HT Condor jobs. You can download data from the OSDF using the Pelican clients. If it's public read, then anyone who has the Pelican client can do this. So it's a command Pelican object get in that same OSDF URL that you use to working with your data. And there's other ways that you can interact with the object as well. You can get objects, so download them. You can put objects, which means to upload them. You can LS them, and there's a few other things as well that you can do. And the client is a standalone binary that you can download from the Pelican websites. And you don't need root to run it or anything like that. So it's and this is just one of the ways that you can use Pelican to access data. There's a few other options as well. Okay, so briefly a note on Pelican URLs. Pelican uses this particular URL syntax for specifying locations within a federation. The first part is the protocol. So default is Pelican. Then we give it the federation's host name and root address. And then it's the object path within that federation namespace. For the OSDF, we always have the same federation. It's always this OSG8-HTC.org as the host name. And so what we've done is we've created a new protocol where it just assumes that that is always the host name. So the OSDF protocol that you see me reference behind the scenes, that actually gets converted into this Pelican URL. And you can use either one interchangeably within HT Condor jobs or within Pelican clients. Okay. So another hands-on portion, if you haven't already done so, you can open up a guest notebook to notebook.ospool osghtc.org. Log in with your institution ID, select guest notebook, and go to this tutorial-r-noah directory. I've already done this in my other window, which I hopefully still have open. Cool. I'm going to close out some tabs here since I no longer need those. Let's see. On the left-hand side, if you're in this tutorial-r-noah folder, there's this new directory, or I mean, it was there to begin with, Pelican-features. So go into that, open up the IPYNB file, and we're just going to run through this here in the hands-on portion. Okay, so this is guiding us through a few different things here about Pelican. But the short version is if you have HT Condor, you have Pelican, or you should have Pelican. If it's a version of HT Condor that's been released in the past year, you should have Pelican. So we have access to this in the guest notebook instance. Also AP40, AP20, 21 also have access to this. You can confirm that it's there by running the Pelican objects --help commands. Objects is for interacting with objects in the Federation. There's a whole other set of subcommands with Pelican for doing all sorts of other things. But for us, we're just going to focus on the object part. We see there's a few other commands here: copy, get, ls, put, share. I think sharing is still a relatively new feature. I haven't even tried it yet. Okay. So in general, the idea is there's this Pelican object, one of those subcommands, and then the OSDF URL that you want to interact with. And there is a test file that we have in this Pelican platform namespace under the test directory. So I'm just going to list the file. If you can list a file, it usually means that you can also download it. It's not always true. But in my experience, that's been the case. So here I listed, I just wanted to ls this object. So I wanted to make sure this object existed in the namespace, and it returns the name of the object. That means it exists in the namespace. I can also list objects within a particular prefix of the namespace. So you in Unix lands, you would, or POSIX lands, you would think of this as a directory. It's a little bit more complicated. Pelican operates under the buckets and objects approach, like S3 does. So directory doesn't quite translate correctly into that syntax. But for all intents and purposes, we are listing the contents of the directory here within the Federation. You can also do -L with that to get the size of the objects and when they were last uploaded, things like that. Okay, so that's pretty straightforward, but also not too interesting. Usually, if you're using the OSDF for Pelican, you actually want to get data or upload data. So for downloading data, you use Pelican object get. You give it the OSDF URL that specifies the object's location within the Federation. And then, oh, I double-clicked again. And then you specify where you want it to be saved in your local storage system. So basically, it's like a copy command. You have to provide a destination. You can also rename the objects on copy. Or you could also think of it as an SCP. So here I'm downloading this hello world .text, and I'm keeping its file name. I'm not changing it. And when I do that, what I see, there's now this hello world .text file. If I open that up, I see a success message. I downloaded this object from the OSDF. Okay. But if I wanted to rename that file to something else, when I give it a location, I can just give it a file name, and it will download the objects as that file. I see now I have a new my local object.txt, and I may need to refresh my file pane there. Oh, there it is. And if I open that up, it's the same data as it was before. Okay. All right, so that's pretty straightforward, and you can do this for, this is just a test file, but, in principle, you can download larger files this way. And in those cases, you'll get a progress bar that shows the progress of the transfer that's happening. I mentioned those HTML queries that we can use. We can also use those in the Pelican client commands here. So if I wanted to download a whole quote-unquote directory from the OSDF, I could tack on question mark recursive at the end of my OSDF URL. So earlier when we did the ls commands on Pelican test, we saw that there were 2 files in that location. If I wanted to download all that data, I would do a get commands and tack on this question mark recursive at the end. And now when I download it, it's going to create a directory with the same name or same base name as that path. So here that was test. And if I look inside of test, I'll see that I have those 2 hello world files. I can also rename or change what the name of that directory is going to be. So I could make download it as this directory, my local objects. And when I look inside of that new directory, I will see those same files again. Okay, so that's nice. That works with the Pelican commands. And like I said, with Pelican, you just have to download the clients, the binary file to your computer, and you should be able to do these exact same commands that I've just done here. That isn't the purpose of our training today, though. Here we're interested in sort of the Condor aspect of it, but this is something that you can do locally. You don't have to do this as part of Condor job. So we do have a test submit file here, recursive.sub. The executable for this is a script that just lists the contents of the job's working directory. Here is a particular OSDF URL that I've set up here under our public training directory. I put a couple of example CSV files there from the NOAA data set that we were looking at earlier. And I just want to download all of those as part of my HD Condor job. And then my list contents.sh will just list that those files exist. Usual setup for the rest of the submit file here. So I'm saving the messages into output, .out and .error and .log, minimal requests here and queuing one job. So I'm going to go ahead and submit that. We'll see a log file immediately created. If I go back to that terminal view, I can do Condor watch queue again. Oh, and it was too fast. It's already done. So in that case, I refresh and I see I've got my .error and .out files, and the .out file should have the contents or list the contents of the directory of the job when it was executing. So we see our script. We also see this NOAA folder that corresponds to the folder created from the base name of the path we provided. And then these are the contents of that directory. Not sure what ordering it's doing there. It doesn't look alphabetical to me. And then the standard out and standard error files. So yeah, and that's what it says here. So this worked as expected. So if you do have a directory of items in your OSDF location that you want to download as part of a job, well, you just need to give the OSDF URL and tack on the $ recursive functionality. Okay. $pack. So we talked about this in the slides as well. Simplest to use is just auto. It does most of what you want it to do automatically. So on download, it will automatically decompress an object. On upload, which we won't be testing here, it will automatically compress into a single object. So why is this useful? Well, let's do it the normal, quote unquote, way. So here, there's a tar file in that NOAA folder I created in the public space, and I want to download that here, and I want to use the files, or I want to have access to the files inside of that compressed directory. So I download it, and then I need to decompress the tar file. So I got to do the tar commands, and then it'll create that ghcnd files directory. And inside of there are some of those climate CSV files that we used in the earlier examples. All right. Now, what's important to note here is that in this manual approach, there needs to be enough disk space, both for the original tar.gz file, as well as for the extracted contents that you created. And if you're working with a lot of data, doubling your data space for both those files can be a bit difficult. All right, so this is where the pack option is going to be useful, and I'm just going to run this cell to remove these files and reset. Let's see here. Okay. Now, I meant to I'm not sure why that one didn't delete. There we go. Probably because I was in it in the file navigator. So now I can combine those two steps. I can both download and decompress the object from the OSDF in the same step by appending on this $pack, or sorry, not $, question mark pack equals auto. So I can run that command. I see it downloading the contents here. And if I ls, I'll see that there isn't a .tar.gz file here. It's just that extracted directory, and inside of that are the files I wanted to access. So we've seen folks use this on our local system to great effects for transferring very large data sets. On the OSDF, on the OSPool, you can't really transfer too large of data sets. 20 gigabytes is probably the typical upper limit for data sets on the OSPool. But with Pelican, in theory, you can go larger, and using this pack feature can help make the organization simpler. We can use this in an HT Condor job. We've got another example submit file here. It is almost identical to what we saw before, except the names are pack instead of recursive, and we're using the question mark pack equals tar.gz option at the end of the URL. We can submit this and watch it go. Let's see if I'm fast enough this time. And it shouldn't take too long to run. It's already done on my end. And if I take a look at the .out file, I'll see pretty much the same thing that I saw locally, except this is now inside of the HT Condor job. And something that's nice about declaring these things in the submit file is that means these files are automatically excluded from HT Condor's check for output files. By default, HT Condor transfers back any new or changed file from the job directory. And by declaring these files to be transferred to the OSDF and in our submit file using transfer input files, it ignores these when it considers what objects it should bring back. So that's really convenient for just management as well, because chances are, if you're using the OSDF to transfer large files, you probably don't want them to come back to your home directory on the access point. All right. That's actually the end of the hands-on portion. I do have a bit more text and examples here about upload and protected objects. So upload, in theory, you would use Pelican object puts, and then what the thing you want to upload, and then the OSDF URL. And if you're uploading the directory, you can throw on pack at the end to have it automatically compress the objects. Same idea in the HT Condor submit file. You set transfer output files to transfer back the files. Use remaps. I'm sorry. Use remaps here to declare that you want this to be saved into an OSDF location, and you provide the URL. So this leads into something that I haven't really touched on yet, but getting protected objects and writing objects of any type in the OSDF requires authorization. So the files we've been downloading have had public reads enabled. That's something configured for the namespace itself. And that means anyone with a client can download these files from the OSDF. So that's why I was using them today. We don't have to worry about credentials. To write an object or to access an object that does not have public reads enabled, then you need to provide some sort of authorization token valid for that namespace. And for our HT Condor jobs, this is handled automatically behind the scenes with HT Condor in our, at least on our general access points. We've configured our access points for this sort of setup. So this happens all automatically behind the scenes. But if you're working not through HT Condor, you're working through something else, then using the clients, you'll need to provide some sort of authorization token. Pelican does have integration with CI logon and or can be integrated with CI logon and OAuth 2 providers to provide this authorization, which for the user makes things pretty easy behind the scenes. So just as an example here, on our AP40 origin or on our AP40 namespace in the OSDF, if you have an account on AP40, then what you can do is on your local device, you can do your Pelican object get commands. You provide the OSDF URL to your location or to your object that you want to download. And when you run this, it'll prompt out something about, do you want to encrypt your configuration? General answer is probably yes. But then once you've done that, there's this section where it asks you to approve the credentials, this operation, by navigating to this web link. And this is automatically generated each time you need to authorize something. In this case, you'll see a CI logon for the AP40 data space or namespace. And in my case, I logged in with my Wisconsin-Madison ID. It says you've successfully approved the user code. And if I have the authorization to download that object, the download just works. And future downloads from that same namespace will use that same authorization to download objects again. So what can be really nice for that is, you want to more easily download your files from the origin. You've got a bunch of output data on the OSDF namespace for AP40. You want to download it. Here's an easy way to do it with the Pelican client. In principle, you could do this same thing in reverse if you want to write data into a namespace. And if it has CI logon enabled, you'll go to the web address and authorize and things like that. For my testing, the AP40 and AP2021 namespaces do not have write enabled, at least not for this approach of writing data. You must have to be part of the HG Condor job submission in order to do that. But for other access points, other namespaces, you can use the Pelican clients who both write and download data from the OSDF. Okay. Switching back to the slides, we're getting near the ends of our time here. So I'll try and get through this. I don't have too much left here. So contributing to the OSDF. So this is one thing that I mentioned Pelican is going to be good for if you want to contribute to the OSDF. It's a lot easier than it used to be because of Pelican. So what does that look like? So first, I guess, why would you want to contribute, or who would want to contribute? You've got, like I said, a public or a data set that you want to make publicly available so that folks can do research on, either as part of doing large scale computing on the OSPool, or even just to make it more easily accessible through a single OSDF URL. You can connect to this, and because of how the OSDF is set up, you don't need a very beefy web server to serve that data. You just need something that can connect to the OSDF, and then the OSDF and its caches will handle a lot of the load for you. If you have an access point and you want to integrate it into the OSPool, using Pelican as to serve your data there is going to enable large scale data movement. So like I was talking with Joseph earlier, if your organization has its own access point, chances are you also want to move data through the OSPool. Well, you can use Pelican to connect to the OSDF so that integration is automatic like it is for general access points. Why should you use Pelican to do this? Well, in general, network effects. And what's really nice for this is we're hoping to one day in the glorious future to have Pelican as a single tool set for accessing data from many locations and many repositories, much of the same way that GitHub is convenient for accessing code. We're hoping we can do kind of the same thing with Pelican and data. And what's really nice about Pelican here is that your authorization policies are reflected throughout the system. So, if someone pulls data through the system, it gets cached somewhere. That cached copy of data is still going to have the same access requirements as it would have if it went back to your original storage. So, creating that proper token, you have to have the proper token in order to access the data. Maybe it's only, read only, no writes, things like that, that will propagate throughout the data access. All right, you want to add data to the OSDF? Well, we do this by setting up something called an origin server. So the origin is a service that talks with your storage device and converts requests from the OSDF into something your storage device can understand. It also serves as the way of authenticating access. We, the OSG, can host the origin for you in certain cases. If you are interested in that, you can just send us an email and at our support address, and that will kick things off. But you also can host your own origin. You'll probably still want to send us an email just to get coordinated about what you need to do to make that happen. But in principle, you could serve this on your own hardware and manage everything directly yourself. So what can we do here? So origins can currently export data from POSIX, web servers, S3, whether it's AWS or others. We have an experimental implementation for Globus. I don't think it's very robust right now, but it is in our development targets. There's a lot more information in the docs of the Pelican website. You can follow that link there. The short version here, let's say you do have that public data set that I was talking about. Then what you need in order to self-host is a server with a registered web domain connected to your data store. You configure the origin service to run on that web server. You run said origin service, and then you need to coordinate with us as the owner of the federation in order to register the service under a given namespace. There's a key exchange there for establishing trust. If you're serving non-public data, it's all of this same stuff I've said so far, and you need to configure authentication services. So that could be a custom token generator, that could be CI logon or OAuth2. Just in some sense, you need to be able to generate tokens to give approved users read and or write access to your storage via the origin. One of the nice things that Pelican has done as part of modernizing the software stack is we've got web interfaces for a lot of things, so you can monitor and you can even configure your origin through a web interface, which I think is pretty slick. We are working on a web-based client, so a way of accessing the data just through your browser, but that's still in its pretty early stages of development. If you are interested in hosting your own origin service, I recommend that you check out this training from last summer that I gave about how to set up an origin. There's a recording of that presentation, and that should hopefully give you a bit more information about what's involved in the process. And lastly, something that is very new as of like a month ago is something that we're calling the OS store. So there are quite a few institutions that, as part of their CC Star storage grants, they need to delegate like 20% of the storage that they're given to open science of some sorts, and the PATH project in the OSDF satisfies that requirement. So this is storage, just raw storage that people are contributing to the OSDF, much in the same way that folks contribute compute power into the OSPool. And what the OS Store program is connecting this raw storage with publicly funded data sets. So science projects that need to have their data accessible, publicly accessible, and would like to do that through the OSDF, but they don't necessarily have, you know, a robust storage service to back end it. We can match them up with some of this raw storage in order to serve their data sets. Now, it's important to note that we aren't backing up the data, right? This is not an archival set up here, but it is a way of making data more publicly accessible. A couple examples of this, there's the SAGE project, which currently has 100 terabytes of sensor data at the Nebraska's NRD store, which is another one of these storage grants. So just raw storage there. The Meerkat telescope has a bunch of radio astronomy data, 250 terabytes used by the NRAO community, and that's being put on some storage space in Purdue. And in principle, if you've got your own data set, we'll be happy to explore the options and see if we can host it. It does depend on sort of what your access requirements are and the amount of data that you have that you're trying to serve. But we'd love to be able to utilize this raw storage that folks are giving us access to. And we're hoping to make all sorts of public data sets a lot more accessible through the OSDF. All right, that was a lot of information, so I appreciate you folks listening. If you have any questions, I have time for one or two, ideally about OSDF or Pelican. Otherwise, we're gonna have to run. All right. Looks like someone tried to do a download from AP20. That will probably require authentication. If it didn't let you authenticate, then maybe it doesn't work. I'm also not sure if AP20 has that enabled. I thought it did, but I didn't actually test that. So
I see. So it gives me a authentication link. I click on it and it went through. It asks me to go back to terminal. When I go back to terminal, it says precisely failed downloading because of the forbidden 403 forbidden server.
It could be that you authenticated with the wrong ID. So it needs to be the same ID that you use to log into your AP20 accounts. Otherwise,
ID is simply just ask me to use the CI login, and then it only tells me to choose my institution. I chose that one, and then it did not even ask for password or username. It simply says that go back to terminal.
Yeah, that probably means you're already logged in somewhere in one of your browsers. Right. So this is it's kind of a silly thing to try, but just try it again. I have had so run the command again, and if it asks you to go through that process, go through the process again. There's still some, I don't know, it's not as robust as I would like it to be. If it still doesn't work, then we do have office hours here in a few more minutes. You're welcome to hang out there and we can walk through it together.
Right. Thank you.
Yeah, so towards that end, we are the facilitation team. We're here to help you use the OSPool, use the OSDF. Any questions, you can send us an email at the support address. We do have monthly trainings like the one today. You can find that information on our training page. And of course, we got a bunch of documentation on our website as well. Finally, this is all based on work grants from the NSF, National Science Foundation, as part of PATH grants, as well as part of the Pelican Platform grants. Usual disclaimer here about who we're representing. And then feedback, we'd love to have any feedback that you have about today's training. We've got a form here you're welcome to fill out. We'd really appreciate that feedback so we can help make these trainings better for the future. And I think that's all that I have for my slides. So thanks folks for stopping in, and hopefully you found this information useful.